All right, let's have a look at de Moivre's theorem. And in de Moivre's theorem, we have trying to get a complex number raised to a certain power. It could be a whole number or it could be a fraction, so any rational power. So we can actually use it to solve problems. So what de Moivre's theorem says is pretty much r cis theta to the power n, where n is a rational number, is equal to r to the power n cis n theta, where n is rational. So that's pretty much what de Moivre's theorem is. So what we pretty much do is we multiply the moduli, plural form modulus, or raise it to the power, raise power, and we add the arguments. Cool. Let's have a look at an example. All right, so let's simplify z to the power 4. So what we do is pretty much follow the rule. It becomes raised 2 to the power 4, and you multiply pi over 2 times 4, and you end up with 2 to 4 to. You can use a calculator for that. You get 16 cis 2 pi. Now you have to simplify it further, because it loops every 2 pi. 360 degrees you have a loop. So if you have anything bigger than 2 pi or more, you minus the value with 2 pi. So 2 pi minus 2 pi is 0, meaning this will be 16 cis 0. And if you expand this in 16 cos 0 plus I sine 0, oops, sorry, 0 not theta, my bad, 0, and therefore it's 16 times cos of 0 is 1, and a sine of 0 is 0. So 16 times 1 plus 0 if you want, that's 1, which will give you 16. Therefore, when you simplify it, you simplify it all the way down, and you just get a real component of z to the power 4, and there's no imaginary component now. So if it's you can just use the whole value in your calculator if you want. You can give cos of 2 pi here and sine of 2 pi here, and you end up with the same answer. All right, let's have a look at another example. All right, so if you're given the complex number in a rectangular form, how are you going to raise it to a certain power? Well, you can't. So you have to convert that to polar form first. And to convert that to polar form, the first thing I would do is draw it on an Argand diagram. And so -1 would be somewhere there, and I would be 1i, so somewhere or 1 there. And if you take that up as a vector, so modulus would be square root of 1 square plus 1 square, which will give you square root of 2. To find the angle, it's a bit tricky. You can see it's 1, 1, so this will be 45 degrees, which is pi over 4. So you can use any means that you have to reason it out. So I will just go, this is pi, all the way from 0, that way. I'll just go pi minus pi over 4, which will give me 3 pi over 4, which is 135 degrees, but you can figure it out in any way that you are comfortable with. Therefore, to write this down in polar form, it becomes r cis theta, which is equal to square root of 2 cis 3 pi over 4, which you want to raise to the power 12. So now you apply de Moivre's theorem. So square root of 2 gets raised to the power 12. Cis 12 times 3 pi over 4. And if you want, you can simplify it. 2 to the power half times 12 will be 2 to the power 6, which will give you 64. 64 cis 36 divided by 4 will give you 9 pi. 9 pi. So if you want to simplify this further, you find multiples of 2 pi and minus it. So 9 pi will give you the same cycle as 9 pi minus 8 pi, which gives you pi. So you can rewrite this as 64 cis pi. You can use that in the calculator if you want to in terms of the expanded form. So this is 64 cos pi plus I sine pi. And then you can substitute the values from there, which will be minus 1 and 0. 64, well actually you can put this in a bracket if you want, times minus 1 and sine pi is 0, so this will be 0. You can put plus 0 if you want, which will give you negative 64. In here the question said evaluate, so that would mean find a value for. And you found a value for raising the polar number to power 12. Alright. Let's solve problems using complex, for a complex number using de Moivre's theorem. So if, for example, the question is z cubed is equal to negative 1, so in order for you to solve this, you have to take, raise it to a cubed root or raise it to the power 1/3 on both sides. Now the first thing you gotta do is take negative 1, which is rectangular, and find out the polar form. So the easiest thing to do there is draw an eigendiagram. So if you draw an eigendiagram, and that is to find your angle theta, and also your modulus actually. So negative 1 is the real component, so it becomes negative 1 there, and therefore your modulus would be 1 because it will be square root of 1 square plus 0 square, which is 1. And the angle would then be, sorry, oh, why is that moving? The angle would simply be pi. It won't be negative pi because it goes in the second quadrant. Therefore, you can write negative 1 as 1 cis pi, or just cis pi. So z cubed equals cis pi. If you want to find z is equal to cis pi to the power 1/3, take the cube root to get z, and that'll be your first root. So z1 equals 1 to the power 1/3, which is 1, and then cis pi times 1/3, which will be pi over 3, and that's your first root. Now this particular eigendiagram was just to find the angle for just for conversion from rectangular to polar. Now what we do is we use an eigendiagram actually to represent the solutions. So you draw another one, and pi over 3 is somewhere around 60 degrees, so you show that here. So that's z1. Now to find the rest of the solutions, it's quite straightforward. Think of a circle, look at the power. The power is the number of solutions. If you set to the power 3, that's the maximum solution, there is 3. So if z1 is pi over 3, pretty much what happens is from this point, I'll use a different color, from this point onwards, this circle is kind of divided into 3. And so if you go, what's the circle? The angle of the circle, it's 2 pi. If you divide it by 3, you get 2 pi over 3. So this kind of is your separation between the angles. So if that is pi over 3, if you add 2 pi over 3 to pi over 3, you end up with pi. And that is your second solution. And the third solution is you add 2 pi over 3 to this, and you end up sort of this way. It comes here. Now the angle is there, but you can't use that angle. The angle has to come from x-axis, moving down like that, and so that'll pi, and that'll be negative pi over 3. So your other two solutions will be z2 equals cis pi and z3 equals cis negative pi over 3. So normally the question would be find the roots of the complex number, and you've got 3 roots, z1, z2, z3, because it's raised to the power 3. And so there's other ways of doing this, but this is the shortest and the most simplest way to solve using the Moivre's theorem. Alright, let's find the roots of z cubed plus 8 equals 0. So if you just rearrange, you get z cubed equals negative 8. And so if you want to find Alright, so the first step for you to do is convert this to polar form. And so if you draw a Argand diagram, negative 8 will stand somewhere there. The angle would be pi. The modulus would be square root of 8 square, 8 square plus 0 square, which is 8. So positive 8. So then your z is equal to positive 8 cis pi to the power 1/3, because z is to the power 3. So you take raise it to 1/3 on both sides, you end up with 1/3. And so that's your first root, which is z1 is equal to, now you apply the Moivre's theorem, 8 to the power 1/3 or cubed root of 8. You can use a calculator. Cis pi over 3, because you go pi times 1/3, which is pi over 3, which gives you z1 is equal to 2 to the 4 is 8. So yeah, 2 cis pi over 3. That's your first root. So you use another diagram to actually draw the solution. So this is to the power 3, therefore 2 pi over 3 would be your separation angle between your 3 solutions. Pi over 3 is 60 degrees. 60 degrees? Yeah, 60 degrees. So it's somewhere there. And that's your first solution. Add pi over 3 to 2 pi over 3, you end up with the pi. This is very similar to the previous one. And that'll be pi. And add 2 pi over 3, and that'll be this side. And that'll be actually minus pi over 3. So your z2, second root would be 2 cis pi. And the third one would be z3, which would be 2 cis minus pi over 3. And so the solution for this particular question would be these 3 roots, 1, 2, and 3 in the 360 degrees. Now usually you don't model the range 0 to 2 pi. It actually falls between negative pi. Sorry, should write that better. Negative pi less than equal to theta less than equal to pi, which is 360 degrees. Goes, so that pretty much means all the way from there around. Cool, let's do some more. Alright, so let's solve a power 4. So z to the power 4 plus 4 equals 0. Z to the power 4 is equal to negative 4. So the first thing you do is write it in polar form. Negative 4 would be, so something there, negative 4. Theta would be, or the angle would be, sorry, not negative, but pi. The modulus would be 4. So we write it is in terms of polar form. You get z equals 4 cis pi to the power a quarter, because you have to raise both sides by a quarter. Right, so z1, that's z1 equals, so if you raise 4 to the power quarter, so 4 to the power quarter, fourth root, cis pi over 4, pi over 4 because it's quarter times pi, and therefore you end up with the square root of 2 cis pi over 4. You can check that with the calculator, and that's z1. Now you draw an eigen diagram to represent all the solutions, and pi over 4 is 45 degrees, therefore choose a different color. You can make that as your first angle, and that's pi over 4. Now what you do next is you take 360, which is 2 pi, and you divide that into 4, because you end up with 4 solutions to the power 4. Yeah. So 2 pi divided by 4 is pi over 2, like 90 degrees. 90 degrees actually. So if you add 90 degrees from here, you end up with your second solution. Add 90 degrees more, third solution, fourth solution. So starting from there, that would be, well, actually that would be 45, right? So pi minus 45 would be 3 pi over 4. I'm thinking, yeah, that would be 3 pi over 4. So you use your reasoning and your logic, and you should be able to, and that will be minus pi over 4 and minus 3 pi over 4. So your z2 in any particular order would be square root 2 cis 3 pi over 4. Z3 would be square root 2 cis minus 3 pi over 4, and Z4 is square root 2 cis minus pi over 4. So these solutions can be given in any order that you want, and there you go. Cool. Thank you for listening.